LearningMeasure.tv, science and engineering podcast with emphasis on measurement. Brought to you by David Archer and LearningMeasure.com. Episode 10. What is a dB? Hello, I'm David Archer. I'm the owner of LearningMeasure.com and LearningMeasure TV. This podcast is sponsored by TradeBub.com, GoToMeeting.com, and is part of the Blueberry series of podcasts. I do want to, this episode, first of all, I want to apologize for the last episode. It was not my best, as I probably shouldn't have tried to do it with all the things that were going wrong. But, oh well, what's done is done. I wanted to talk a little bit about LearningMeasure.com before we get started. LearningMeasure.com is the website associated with this podcast. It is a technical training site where there's a series of courses you can take online. We have just started a subscription service. So now that the courses, you still get a free 60-day trial when you register as a student. But then if you want to continue supporting development of new courses, this podcast, you have to subscribe. And the subscription rate we've decided is $5 a month. So after your 60-day free trial period, you can continue supporting us for $5 a month, and that will help keep us going and help keep the courses being developed. In this course, we're going to discuss dB, or decibels. I said course, this episode, yeah. Most of the material here is found in one of our online courses, EE 103, Introduction to the Decibel. Okay. First thing the decibel is a power ratio measurement or a power measurement. It's a logarithmic scale. You might be familiar with other logarithmic scales like the Richter scale for earthquakes or the magnitude scale in astronomy. Those are all logarithmic scales. The reason we use a logarithmic scale for power basically is the human ear. The human ear basically has a logarithmic response over a fairly wide range of powers. So it was natural to come up with a unit that was a logarithmic unit because the ear does. In fact, 1 decibel is roughly the smallest change in sound power that the human ear can discern. But before we get into what the decibel is, let's get into what the logarithm is. We know what taking something to a power is, like 10 squared is 100. It's 10 times 10. Okay. Well, you can take something, let's say what's 10 to the x power. Let's say that equals something. Let's say y. Well, how do you solve that equation? Answer the log, base 10. So the log base 10 of 10 to the x equals x, which equals log base 10 of y. Now you should have seen this in your calculator. You can have different bases in logs. You might have seen this in high school too, or maybe even junior high. So basically the log does taking something to a power. There's a special log that undoes this special number e to the x equals something. Okay, the solution to this is x equals what's called the natural log of y. Now you got to be careful if you're going to implement calculations in computer languages. Log might be the natural log, it might not be the base 10 log, and that's what we're going to talk about in a minute. Let's talk a little bit about some properties of logarithms. First of all, the number, it's written log and then some number here called the base of x. Okay? It could be 10, it could be e, it could be 2. In computer science, a lot of times you'll see log base 2. Well, if you have a log base b and you want to know what that is in log base c, you want the log of x in log. How do you get that if you know this? Well, it's easy. You take the log of base b of x and you divide it by the log base b of c. So if you want to go from the natural log in particular to log base 10, log base 10 of x equals ln of x divided by the ln of 10. Now, since 10, okay, what is log of 10 in base 10? Okay, well, we'll say that in a minute. Well, no, actually, no. We got 10 to the 1 is 10, right? So log base 10 of 10 equals 1. Okay, so if you tried to convert log base 10 to log base 10, let's say, and you did this division, it wouldn't do anything because it's 1. So it's always safe to do this. So if you have a computer language and you don't know what the base of your logarithm is, it's always safe if you want to take a logarithm of a certain base, and you take, okay, whatever the number is, let's say y, divided by log of 10. Okay, that will always give you log base 10 no matter what your logarithm is. What are some other properties of the logarithm? Well, log of xy equals, regardless of the base, log of x plus the log of y. Well, this is a useful property and one of the reasons why you want to use logarithms. Because what the logarithm does essentially is reduce multiplication to addition. So if you can do addition faster than multiplication, you can do calculations faster. What about another thing? Let's say powers. What's log of x to the n? Okay, log of something this. Well, it turns out this is n log x. So taking the log reduces exponentiation to multiplication. So it makes things a little bit less complicated. In particular, log of x squared equals 2 log x. Okay, you'll see that in what's going to follow here. Some other properties of the logarithm. Log of x divided by y equals the log of x minus the log of y. Okay, another nice property of logarithms. Those of you into ancient history may have known there was some device called a slide rule. A slide rule was a way to do these type of calculations using logs and addition, essentially. That's all it was. Some of you might not like the fact that I'm calling it ancient history, but nobody uses them anymore. Okay, so now that we have the little idea of what a logarithm is, I got to pay some bills. Okay, do you spend more time traveling to meetings than you do actually meeting people? If your time is valuable and whose isn't, then you need GoToMeeting. With GoToMeeting, you can instantly meet with anyone. All you need is a PC and an internet connection. During the meeting, your attendees see on their computers what you show on your PC. It's like you're in the same room. Plus, it's totally interactive. You can all work together to make changes to a report, add slides to a presentation, even show someone how to fix their computer. Think of the time you'll save. No more driving or flying to a meeting. Plus, you can hold as many meetings you want for one low flat rate. It's a real money saver. The next time you're waiting in line at the airport, you'll wish you could meet online instead. So sign up right now to try GoToMeeting free for 45 days. For this special offer, visit gotomeeting.com/podcast. That's gotomeeting.com/podcast. Try it free now. Okay, well, now we talked a little bit about logarithms. Okay, well, what's a decibel? Well, we already said the decibel is a logarithmic unit. It's named after this guy here, Alexander Graham Bell, who is attributed with inventing the telephone. He invented a whole bunch of other things like the hydrofoil. He's interesting character in history. You might want to look him up sometime. Anyway, the decibel, well, the decibel is a unit, is a tenth of a bell. If you know the SI prefixes, you know that, M is 1/1000th, D is 1/10th, C is 1/100th, etc. K equals 1000. So a decibel is just a tenth of a bell, written dB. Okay, small d, capital B. The capital B because of it's named after a person. However, when you write out decibel, it's all lowercase. Decibel. Oops. Okay, so what is a bell? Well, a bell is a log base 10 of a power ratio. It's log base 10 of 2 powers. That's a bell. So the number of bells is that. A decibel, there's a 10 decibels to a bell. So a decibel is 10 log base 10 of some power ratio. Now, you may have wondered what dB was on your, like your audio stuff. It's maybe a graphic equalizer. And there's numbers there, 0 through whatever. Well, those are just gain numbers, or it might even be, there's something called dBSPL. But we'll talk about that in a minute. So if you had two numbers, for instance, you had, what's 2? What's a factor of 2? So what's log base 10 log base 10 of 2? Well, this is about 3.01, or which is 3.01 ... which is approximately equal to 3. So in dB, a factor of 2 is basically 3 dB. So remember, it's power ratio. Now, if you know a little bit of electronics, you know that power is proportional to the voltage squared. So a voltage ratio, which is a power ratio is going to be V1 squared over V2 squared, right? So log base 10. Well, this is the same as this whole quantity squared, right? So 10 times this quantity squared. So this comes down here as a factor of 2. That's one of the properties of a logarithm. And you've got 20 log base 10 of V1 over V2. So you'll see this a lot for voltage ratios. There's a factor of 20 up front. That's just because this 2, the square term, multiplies the 10 in the definition of the decibel. So if it's power ratio, it's 10. If it's voltage ratio, it's 2. Okay? Now, there's absolute dB units too. For sound pressure level, the 0 dB, that means there's a reference power level, which is considered the threshold of human hearing. So 0 dB sound pressure level is 20 log times the pressure, in the sound wave, divided by a reference level, which is 0.00002 newtons per square meter. Okay, so obviously power is proportional to the pressure squared in the sound wave. So it just so happens that's the standard reference level chosen for human hearing. Like I said, 0 is the threshold for human hearing. 70 dB is something like a noisy restaurant. You can get up there 140, I think a jet engine, something like 140 dB SPL. So that's that. What are some other units? Well, it's power ratios. We know that power is measured in watts. In particular, you can have a unit called a dB watt, which is 10 log base 10 of power divided by 1 watt. Okay. So the reference for a dBW is 1 watt. A dBW is the number of dBs above 1 milliwatt or below, if it's negative. There's also something called dBm. dBm. Well, that's dB relative to a milliwatt. And that's power divided by 0.001 watt. Okay, power in watts. You can have also dBV, dB relative to a volt. It's going to be 20 log, because this is voltage, of V over 1 volt. Correspondingly, there's dB millivolts, there's dB microvolts. You don't talk too much about dB microwatts, but you sometimes see that, dB microwatt, dB relative to a microwatt. So these are all now absolute measurements because you've specified a reference point. Now, also an interesting unit in dB that you sometimes see in some books, in some reports, is the dB dollar. Well, everybody knows that money is power, so a dB dollar is 10 log base 10 of your money in dollars. So now if you wanted to reduce the national debt by half, you reduce it by 3 dB. What is the national debt now? I forget, in the United States. It's something on the order of, it's 12, something like like 26 to 30 dB dollars. The average person, probably the average family in the United States, maybe makes 46 dB dollars. Doesn't sound so bad when you look at it in that terms. Also, most engineers would rather have their raises given in whole dB, and we'll see why in a minute. We'll be back in a second.
One of LearningMeasure.tv's sponsors is TradePub.com. TradePub.com is a site where one can sign up for a large number of free trade publications. If you'd like to support this podcast, go to the LearningMeasure.tv site, scroll down to the free publications link, and choose one of the magazines or one of the publications or one of the categories and sign up through that link. Each publication subscribed to through this link on LearningMeasure.tv website helps keep Learning Measure TV on the air. Thank you for your support.
Okay, now that we've talked about that, remember, basically for power, the definition of a decibel is 10 log base 10 of a power ratio, or 20 log base 10 of a voltage ratio. Well, a lot of times you have some equation that define, like a measurement equation of some sort, and you measure everything in dB. Well, you might want to convert that equation to decibels. I'm going to pick one. Got a bunch of choices here. Let's talk about something we've already talked about in previous episodes, the Friis transmission equation. So we got power received is the power transmit times, this is for two coupled antennas, G transmit, G received, times lambda over 4 pi r squared. Well, let's start doing our rules here. To turn this into dB, we're going to take 10 log of both sides. But for the moment, let's move this over here so we have a power ratio. That gives you the loss between two antennas. So you've got 10 log base 10 of the ratio, PR over PT, equals, well, these are all products, so those turn into sums. This is a log of GT in dB, plus the log, base 10 of course, of GR, plus 20 log lambda over 4 pi r. Okay. Well, this last term here is generally called the space loss. So this is equal to gain of the transmitter in dB plus the gain of the receive antenna in dB plus the space loss in dB. So this turns what looks like a fairly complicated equation into a sum of three terms, and this is just the ratio of powers. This term could be further dealt with because that term, space loss, is equal to 20 log lambda minus 20 log r minus 20 log 4 pi. Okay, those are all base 10. So that's how you would deal with something like that. You use your rules for logs, and then you got you can create all these equations to do things by just addition and subtraction. There's one more thing about might want to concern yourself in dB with measurement, is how to express uncertainties in dB. Well, let's say you have some power P, and you know it's uncertain to, let's say, delta P. Okay. Now, if you want to measure this in dBm or something instead of watts, you might want to figure out what the uncertainty is in dBm or dBw or whatever. It turns out that the way you do that is you take 10 log base 10. The uncertainty of P in dB is equal to 10 log base 10 of 1 plus delta plus or minus delta P over P. It's not going to be symmetric generally. Now if you have, what about if you go the other way? You have the uncertainty in P in dB. Let's say you wanted to determine the relative uncertainty, and that's all you have. Well, you can invert this equation, and you'll get the delta P over P, the relative uncertainty, is 10 to the delta P in dB divided by 10, and then there's going to be a minus 1 term. Okay, and this is plus or minus. Okay, so now you can convert uncertainties of your measurement from either uncertainties in dB or uncertainty in watts. You can do something similar for voltage. You just change this from 10 to a 20 for voltage. Let's see, is that? Yeah, so that's pretty much all I wanted to talk about for this episode. Give you a little idea what a dB was. Although we might talk a little bit more later in a later episode. So we're still looking for somebody who'd be willing to come on our show, interview them, show us some measurement equipment, tell us about what you do as an engineer. If you have something you want to be on here, just send us an email at vendors@learningmeasure.tv. And if you have any suggestions for an episode that, some sort of topic you want covered here, send us an email at suggestions@learningmeasure.tv. Well, that's it for this week. I'll see you next week.